Hello and welcome, ladies and gentlemen. This is your manual online mathematics. If today is your first time of visiting this channel, please try to subscribe. We are going to continue with the mathematical induction, but this time around we are looking at inequality. So let's look at how we solve inequality. There's a question. Prove that for all integers, n being greater than or equals to 3, 2 to the power n is greater than n plus 4. So we should prove that 2 to the power n is greater than n plus 4. This is what we are going to prove. If you want to prove this thing, the first thing that you need to do is that you set n to be equal to 1. That's what you have been doing previously. But here, because they are giving us n is greater than or equals to 3, you have to set n to be equal to 3. Say n is greater than or equals to 3. It means that n cannot be 1, cannot be 2. It should be 3 or more. So let's do that. When n equals 3, I'm going to have 2 to the power 3 is greater than 3 plus 4, which will give you 8 is greater than 7, which is true. Is that okay? So we move on. When n equals k, that's the assumption stage, right? That means k will be greater than or equals to 3. But here you replace it by k. Now let's put it there. We have 2 to the power k is greater than k plus 4. Let's hold this. I'll come back to this one. Now let's also look at when n equals k plus 1. Thus we have 2 to the power k plus 1 is greater than k plus 1 plus 4. So let's try to break this one down. We have 2 to the power k plus 1 is greater than, this will give you k plus 5, right? Good. Now, how do you prove this? What you're going to do is that we are going to prove this, or we are going to use this one to help us to get this, okay? So the first thing, yeah, I can make this 2 to the power k look like 2 to the power k plus 1, or k plus 4 look like k plus 5. That's what I'm going to do. So what I'm going to do is that I'll make this 2 to the power k look like k plus 2 to the power k plus 1, which is 2 to the power k is greater than k plus 4. So we simply multiply here by 2, multiply here by 2. So that gives us, this is power 1, so they are the same. So I'm going to have 2 to the power k plus 1. Here will give us 2k plus 8. Is that all right? Now let's see. Now this and that are the same. That is the idea. But here and here, how do you know that this is being greater than this, or this is being greater than that? You have to test. How do you test? By using k is greater than 3. Okay, that means k should be equal to 3. We can use 4 whatever to test between this and this, the one that is greater. You have to know. So if that is the case, let me take k plus 5 first. If I do the substitution, I'm going to have 3 plus 5, which will give us 8. Then let me come and take 2k plus 8. If I do the substitution, I have 2 multiplied by 3 plus 8, which will give us what? 14. So you realize that 2k plus 8 is greater than 5k plus 5. This is what I'm going to get. If that is the case, if 2k plus 8 is greater than k plus 5, and remember, I'm using this one to prove this, and look, and 2 to the power k plus 5 is greater than, and this is also greater than 2k plus 8, then we can say that 2 to the power k plus 1 is greater than k plus 5, which is proven. Okay, look at this. The first thing was that here I just tried to manipulate this to get this one, and I did that and I had it. But here I just wanted to know this and this, which one is greater. Okay, So I just substitute k equals 3. Where did I get k equals 3 from? Here. Can use 4 to test. When you do that, you realize that 2k plus 8 is greater than k plus 5. And also 2 to the power k plus 1 at this place is greater than 2k plus 8. If that is the so, then it means that 2 to the power k plus 1 is greater than k plus 5, which is here. What I'm trying to say here is that if I have 10, let me take this way, 5 greater than 2, then 10 is greater than 5. It means that 10 is also greater than 2. Look at this analogy. So this is proving. Okay, so you can say therefore by PMI 2 to the power n is greater than n plus 4. Proof. Is that okay? Now let's look at another example. Okay, now let's look at example 2. Prove by induction that 4n is less than 2 to the power n for some positive integers. You know that positive integers, the less number for positive integers is 1. So first use when n equals 1 to try if indeed 4n is less than 2 to the power n. So let's try that. So when n equals 1, let's try here. 4 divided by 1 is less than 2 to the power 1, which is not true because 1 is 4. It's 4 can never be less than 2. So use when n equals 2 to try. That is going to be 4 times 2, right, which is 8, less than 2 to the power 3. 2 to the power 2 is 4, which 8 can never be less than 4. Now let's also look at when n equals 3. Okay, so that is going to be 4 multiplied by 3. 4, 3 is 12. 2 to the power 3 is 8. 12 can never be less than 8. So when n equals 4, you take 4 for which is 16. 2 to the power 4 is 16. 16 is not less than 16. So you take when n equals 5 to see. That will be 4, 5, 20. 2 to the power 5 is 32. It's true, 20 is less than what, 32. So this holds. Okay, so let me clean it. So we can set the distance to be that. The assumption will be we want to prove this less than 2 to the power n. So it will be n greater than or equals to what, 5. That's one is what holds. When you substitute it, you realize that this is greater than that, so it holds there. Now let's move on when n equals k. That's going to be 4k is less than 2 to the power k. Okay, so let's hold this one. Now when n equals k plus 1, what happened? When n equals k plus 1, you see this equation can be turned as 2k plus 1 is greater than 4 multiplied by k plus 1. Let me turn it this way so that it will be easy for me. So I have 2 to the power k plus 1 is greater than 4k plus 4. So now this, I need to prove this to look like this. The easy one is this side. Let me rewrite this equation. The first equation, I can write it that 2 to the power k is greater than 4k. So if I multiply here by 2, here by 2, I'm going to have, here's power 1, so I have 2 to the power k plus 1 being greater than 8k. Is that okay? So this is what I have. So this side is the same as this. Let's with this side. So we test this and this by using n equals. Remember, say n is greater than or equals to 5. It means that this place how to be k to be greater than or equals to 5. So let me use k to be equals to 5. 4k plus 4. Okay, if I put 5 into 4 multiplied by 5 plus 4. 4, 5 is 20. That will give you 24. Then let me use 8k. So k is 5. So I have 8 multiplied by 5. That will give you 40. So if you look at this and that, it tells you that 8k is greater than 4k plus 4, right? and 2 to the power k plus 1 is also greater than 8k. Then look at this again. 8k is greater than 4k plus 4, and 2 to the power k plus 1 is also greater than this 8k. It tells you that 2 to the power k plus 1 is greater than 4k plus 4. Very good. So this is proven. We are able to prove that this is indeed greater than this, is indeed greater than that. Is that okay? So you conclude by PMI 2, sorry, 4n is less than 2 to the power n. Proved. Thank you very much for watching.